Wow, thank you so much for joining this lesson. Thank you for joining our lesson. We shall be discussing mathematics paper 2, section 1, a very serious paper that I hope will transform people's thinking, some people's way of taking mathematics. So please now cooperate through this paper until we finish. You're most welcome. As usual, remember to subscribe. As usual, remember our main question: are you a subscribed member of Shifting Grades Online School? Are you? If not, kindly subscribe to this platform. This is where you'll be getting the best in mathematics. So please make sure that you are subscribed so that we may flow together. As we begin this lesson presentation, kindly note our programs. Please take note of our serious programs for the year. We're going to have a candidates mentorship program, which is strictly for mathematics. This one is going to involve the KGCR students or the KGCR learners who are waiting for KGCR in the month of October. Every Saturday from 7:30 to 9 p.m. These classes will be happening on Google Meet. So please, you can reach out through my number for registration and to ensure that you take part, to ensure that you get the best from this particular platform, Google Meet. So please make sure you enroll to our programs. The Form 4s who are waiting for the KCSE, please ensure to enroll. We'll be interacting during Sundays, every evening on Sunday from 7:30 to 9 in the PM. So you are also invited. Then now we have what we are calling now the one-term program from Shifting Grades. Make sure that you are one term ahead. If you are in Form 3, Form 2, and Form 2 and Form 3s, the next year you'll be in Form 3s and 4 respectively. And we are going to cover 2026 term 1, 2026 term 1 work. So as we prepare to cover, one of us enroll by again reaching out through my number. We'll be covering all term 1 work for junior school students. So grade 6 will be in grade 7. 2025 grade 7 will be the grade 8s of next year, and our grade 8s shall be grade 9s next year. So please enroll to this platform and ensure that you get the best. For any inquiries about these programs, my number is public. It's already displayed on the board. Kindly feel free to make use of the number 0704153366. Let me write it here for those who have not seen it. Okay. The number is here. 07. The number is well displayed at that point. So now we can get started. You can now share the link. You can invite a friend as we get serious in the paper now. As we get serious in the paper, let me assemble my tools, my calculator, my ruler, standby, all of them. Yeah. Let's get to number 1 now. Wait, have you subscribed? All right. A carpenter wishes to cut a 2-meter long piece of wood into 3 equal parts. He approximates the length of each piece to 0.66 meters. Calculate the percentage error due to this approximation. Calculate the percentage error due to this approximation. Now, we have what we call percentage errors due to computations. When you add, subtract, divide, multiply, you can get some errors in such a working. But now in this case, we are talking about percentage error due to estimations. So what are we estimating first? We are estimating the length of a wood after dividing 2 meters length into 3. So we are taking 2 meters divided by 3. This one is the actual length. Yeah, 2/3 meters. When we take 2 meters and you divide them by 3 parts, we get 2/3 of a meter. Then now the estimate is going to be 0.66 meters. This one is the estimate or the approximate. That is the estimate value. With that estimate value, now we can say that error in math or error in estimations is usually given by actual value minus the estimate value. The estimate value. Then now, for us to get percentage error now, we take the error itself, divide by actual, and we multiply by 100. So divide by actual value, then we multiply by 100% to make it now percentage error. So let's get the error first. We need 2/3 minus 0.66. Yeah. Then this should be divided by the actual value, 2/3. Then now after this, we multiply by 100%. Let's now check this. You go to your calculator and ensure that you are so accurate, just as I'm doing. 2/3, we subtract 0.66. I'm getting the error, but now I have to direct again from the calculator, divide by 2/3. So answer divide by 2/3. Then now I multiply by 100. You know I'm getting exactly 1%. Please use your calculator and let me know whether you are getting the same value from that side. Number two, simplify 5 divided by 3 minus the root of 5, then minus 3 out of root 5 again. Leaving your answer in the form a plus b root c, where a, b, and c are constants. A, b, and c are constants. Let's check these. We want a, b, and c to be constant. What you're supposed to do here, ladies and gentlemen, as you work out a question like this, you ensure that in SURDS, when the setting is in this format, just treat it as a normal fraction. When you treat it as a normal fraction, you will start handling it by first coming up with the LCM. So what will be the LCM? The LCM shall be, the LCM shall be 3 minus the root of 5. Then all this should be multiplied by the root of 5. That way. Then we proceed by now taking LCM divided by the denominator multiplied by numerator, just like a normal fraction. So LCM divided by the first denominator, we remain with root 5. Then multiplying by numerator to be 5 times the root of 5. Then minus 3. What will multiply 3 in this case? We take the LCM, we divide by the second denominator. So LCM divided by the second denominator, it is root 5 that will cancel. So after root 5 has cancelled, now we will have 3 multiplied by what remains now. What remains is 3 minus the root of 5. So from the numerator, we can open brackets, ladies and gentlemen. We open brackets this way. 5, the root of 5, then minus negative 3 by 3 is negative 9. Then minus 3 multiplied by negative root 5, that becomes a positive 3 root 5. If it becomes positive 3 root 5, we can divide all this by the denominator. So at the denominator, we will talk about opening brackets again. 3 by the root of 5, then minus. What are we minusing? The root of 5 times the root of 5, that becomes root 25, giving us 5 that way, giving us 5. Let us now combine like terms from the numerator. 5 root 5 and 3 root 5 becomes 8 root 5. 8, the root of 5, minus 9. Remember, this one is now being divided by what? This is being divided by 3, the root of 5, minus 5. Then we are supposed now to multiply by the conjugate. Remember, we are now supposed to leave the SURD simplified. You cannot simplify a SURD and you have surd at the denominator. That way you will not have simplified. If at the denominator there are surds, you are yet to simplify. Are you commenting, ladies and gentlemen? Are you telling us where you're watching us from? Okay, thank you. Thank you for being live. Thank you for being live. I'll be getting back to your comments. Let's first progress with the paper, but remember to tell us who you are and how you are reaching us, where you're getting us from. Yeah, that way. So now we multiply with the conjugate of the denominator, 3 the root of 5 plus the root of 5. Not root, sorry, it's a 5 plus 5. That is the conjugate of the denominator. Then we also take it to the numerator to ensure that the effect is well distributed and we don't change the value of the expression. We multiply both at the numerator and also at the denominator. There's a time we had started streaming this paper. Something happened, we stopped. So some of the questions will be a repetition, but we are soon getting to the questions that you have no idea about. From the numerator, we're supposed to take this 8, the root of 5. We multiply by everything in the second denominator. Everything in the second denominator. Then minus 9 into 3, the root of 5. We add 5. So we're supposed to multiply. That way, we will have expanded the numerator. Then we get to the denominator. Remember, it's a surd and its conjugate. When it's a surd and its conjugate, we just multiply the first part squared minus the second part squared. So we shall deal with 3 root 5 squared. 3 root 5 squared, that means 9. Okay, let me write it. 3 the root of 5 squared minus 5 also squared. So that now we find the value in the second step. Let's look at this. We are grouping terms now. 24 times 5, 8 root 5 and 3 root 5. We get 24 times 5. This is 120. All right? Plus 40. That's a 40. 40 root 5. 40 root 5, yeah. Then minus, this is 27, the root of 5. Then minus 45. I hope that grouping of terms or that opening of brackets is very clear, very clear. Then we divide by 9 times 5, which is 45. And this is 25. So we'll be having 20 at the denominator. We shall be having 20 at the denominator. So we have 20 at that point. Then now we'll be grouping terms for the numerator. If we are to group terms, we shall talk about 120 minus 45, right? To give us 75. Then plus, what are we having here? 40 minus 27 to give us 13 root 5. 13 root 5, that way. So with this now, we can check. Remember, it's now correct, but let's get back to the equation. Do we need it in this format? Not really. Not really. We need it in the form a plus b, the root of c. And a, b, and c are constants, not integers, constants. 75 over 20. That gives 3.75, which is 3 1/4. 3 3/4. Plus 13 over 20, the root of 5. So we have split now so that we take the format which is in the instructions. Okay, after that we can proceed now. And ladies and gentlemen, I want you to observe the arrangement of my work. My work is so decent, very decent. So please make sure you organize your work in a very decent way. Very decent way. I can also see my presentation from the other side that everything is properly visible. Let's check the part 3 of this, number 3 of this paper. As we get to number 3, I will bring a question to you. How do you charge airtime? How do you recharge your lines? Huh? How do you load airtime to your lines? Simply, you have to go to your M-Pesa according to our mechanism here. You go to your M-Pesa, Lipa na M-Pesa option. The pay bill number is 737356. Then after 737356, we can now talk about the account number, which is the phone number that you are purchasing the airtime for. So you enter your phone number as the account number. It could be the Safaricom number, the Airtel number, the Telcom number. So after that now, you enter the amount that you'd like to use as airtime. Then you proceed with the transaction. Your airtime shall be reflecting instantly. The airtime reflects instantly. So please use our mode of recharging airtime and invite your friend to the same. Number 3, make x the subject of the formula, given that t equals to x out of the square root of x minus b, then x plus b. Let us look at this now. We are making x the subject. So I would advise, I don't want to copy the question again, but allow me to square both sides. Because there is a square root sign, we square both sides. So this becomes t squared. Sorry for that. Yes, t squared equals to t squared equals to after writing t squared, we will have the other side becoming x squared. Then out of, now the square root sign which was there now disappears, and we will have x minus b, x plus b. Look at this. At the denominator, we don't have to expand using the long method. We're just supposed to know that this is a quadratic identity, a difference of two squares, whereby we say if we have a plus b, a minus b, this one can be expanded directly by just taking a squared minus b. So even if you use the long method to expand, you shall arrive at this. Therefore, with the denominator having the same format, we don't have to use a long method. We just write t squared equals to x squared, divide by, instead of expanding by taking too long, according to trigonometric, not trigonometric, but quadratic identities. According to quadratic identities, now we shall have x squared minus b squared. That is according to the quadratic identities. According to the quadratic identities. Remember to subscribe and also to share with friends as we continue learning together. At this point now, we can cross multiply. Remember, t is automatically over 1. It doesn't have to be written. It's automatically over 1. So we can do a cross multiplication. With a cross multiplication, we shall talk about t squared, x squared, then minus, again, t multiplies equals to x squared by 1, which is just x squared. So at this point now, at a point like this, we can bring together the terms that have x. Remember, it is x that we are making the subject. It is x that we are making the subject. So the terms with x can be taken to the same side. T squared, x squared, minus x squared equals to, now the terms without x are also taken to the same side, to the right, and it will become positive. That way, after taking the terms with x to the same side, we can factor out x squared. Once we factor out x squared, we are remaining with t squared minus 1 at this point. This is equal to t squared b squared. Look at that. B squared, t squared, that way. At that point again, allow me now to talk about, because we have x already factorized, we can now remain with x squared alone. T squared b squared. Then this will be divided by the coefficient of x squared, which is t squared minus 1. T squared minus 1, that way. Yeah, t squared minus 1. So now at this point now, we can talk about the value of x by taking square roots of both sides. When we take square root of both sides, we will introduce plus or minus, because the square root of any value is either plus or minus. Plus or minus. That is a very serious concept that should be taken serious anyway. Please make sure. Yeah. Yeah, that way. So look at this. Look at this now as we continue winding up in that question, not in the paper. We are check now. T squared b squared out of t squared minus 1. Look at this now. We have already made x the subject. So a mark can be awarded at that. But depending on the seriousness and the strictness of the marking in particular years, something that varies from one year to another, you can say that x is equivalent to plus or minus. Now, when we take the square root of the numerator, because the two terms have been squared, we just get actually the square root is known. It will be t and b from the numerator, but from the denominator we don't have the value. From the numerator we can just have t squared minus 1, and remember that t squared minus 1 can also be simplified according to the identity that we have here. This one is an expanded difference of two squares. When it has been expanded, it can be factorized to be t minus 1 and also t plus 1, because it's a difference of two squares. T minus 1, t plus 1. That way. Then remember now to take the root on the denominator alone. So at the denominator we can have the root remaining, but at the numerator we do away with it. Yeah, that way. I hope now you followed through up to the end of this. A logarithm question here in number 4. A serious log question in number 4. A serious logarithm question in number 4. Let's continue following. There are the guys who have never subscribed to our platform. Kindly make sure you subscribe. Make sure to share with friends. Just invite somebody to Shifting Grades Online School, which is the best platform anyway around the globe. Solve for k, given that the logarithm of k to base 3 squared minus the logarithm of k power 0.5 to base 3 equals to the logarithm of 8 to base 2. Let us check this. Let us check this together. I'm going to work out two things at the same time here. I'm going to express 8 to the base of 2 such that we're talking about the log to base 3 of k squared minus the log to base 3 of k power half equals to the logarithm to base 2 of 2 power 3. So instead of 8, we are having 2 power 3. Instead of 8, we have 2 power 3. Now, allow me mention a law in logarithms that says when we have the logarithm, let's say to base a of b power c, this can be solved by making c a scalar multiple at that point. Then we have b to the base of a that way. Now, because of this law of logarithms, I'll be re-expressing my equation. Then I bring half at this point to have the log 2 base 3 of k equals to 3 the log of 2 base 2. The log of 2 base 2. Something else that I want you to get very clear from what we are having here is that the logarithm, this is a law of any number to the same base is always 1. If the logarithm of any number to the same base gives us 1, then we should know that the right hand side now can become 3, because the log of 2 base 2 equals to 1, then multiplied by 3 now. So please master that. Master that the logarithm of any number to the same base is equal to 1. The logarithm of any number to the same base is 1. If that is so, then we're supposed to talk about something here. Look at this, ladies and gentlemen. Trying to check your comments here, and I'm really grateful. You guys are increasing. Make sure I do frustum. Okay, we have done a lot of frustums. Please check in our paper 1 presentations. This is a paper 2. Please check in our paper 1 presentations. I can follow your comments. Check on paper 1 presentation if you want frustums. In case a frustum appears in paper 2, it will be talking about something like 3-dimensional geometry. Yeah, 3-dimensional geometry. So look at this now. Look at this. We can let me write this, the log k squared minus half the log k to base 3 equals to 3. So that part becomes 3. It just becomes 3. Allow me utilize my space so well so that I have well organized work. Section 2 will also be worked out. Thank you for the good concern. Before you open schools, I will present the section 2. Check this now. We will talk about letting the logarithm of k to the base of 3 to be another unknown, which we can even let to be k. If that has been let to be k, then we are having y being squared, then minus half y equals to 3. Can we do away with I was to do away with half by multiplying by 2 throughout, but at this point I've discovered it is unnecessary to do that. Reason being, for us to solve this quadratic equation, we can even use what we call the completing square method. So to use the completing square method, we need to talk about remaining with y squared minus half y at this point. Then we add a constant here, and also to 3, we add the same constant, such that the left-hand side is made a perfect square. Now, how do we make a perfect square from a quadratic expression which is lacking a certain term? The terms in a perfect square are related such that c is usually given by b out of 2 squared. So when we take b in our expression, b is going to have a value which is equivalent to negative half, not half, negative half. So negative half will be squared now. We square negative half. For us to square negative half, then it means it will become 1 out of 16. And we also take it to the other side as 1 over 16 that way. When we've done that, I'll be getting back to your comments, guys. I can see I'll be getting back to your comments. But look at this. At this point, we will be talking about now factorizing the perfect square here. To factorize a perfect square, you take the square root of the first term, which is y, the sign that follows, which is a minus, and the square root of the constant that you've just found, which is 1 over 4, a quarter. squared. It has now been factorized. On the other side, what are we having? 3 and 1 over 16. 48 plus 1 over 16, that is 49 over 16. On the right-hand side, we are having 49 out of 16. At this point now, we can take square root. When you take square root of both sides, you shall have y minus a quarter equals to plus or minus 7 over 4. That is after taking square root for both sides. After taking square root for both sides. So to get y, you now need to take 7 over 4 plus a quarter. 7 over 4 plus a quarter. This gives us exactly 2, or y equals 2. Y shall be equal to what? Negative 7 over 4, the other part of the root, then plus a quarter. This will be equal to negative 7 out of 4 plus a quarter. This gives us negative 1.5. Negative 1.5, that way. Negative 1.5. So now we can talk about the two values of y. We have them standing by. But what had we let to be y? We are not through with the question. What had we let to be y? We had let the log of k to base 3 to be equal to y. So log k to base 3, the log of k to base 3 equals to y. Y is 4, or the log to base 3 of k can be equal to negative 1.5, which is negative 3 over 2. At this point, we can change the statements from logarithm to index. Thank you. Continue commenting and letting us to know where you're watching us from. Let's know who you are. I'm getting back to mention a few guys here. But check here. We know that when we have the log of b to base a equals to c, this is a logarithm statement. This logarithm statement can be rewritten. This statement can be rewritten, and it shall become, this can be rewritten and it shall be in index notation. This one is going to be, when we take a power c, we get b. A power c equals to b. That is changing a logarithm state to index notation. So now we can change the statement. 3 power 4 equals to k, meaning that a possible value of k is 3 power 4. 3 power 4, which is equal to 81. Or we can also say 3 power negative 3 over 2 can also give us k. Are we together in that? Then we apply now indices. This is now logarithms and indices. This is a negative index. So we can take a third, and now the power becomes positive. We take reciprocal, the power becomes positive. So now we can apply the laws of indices again, whereby we are dealing now with a fractional power. When the power is a fraction, and I can see you guys are increasing for the serious prediction paper, I can see you are increasing, and thank you so much. Let's know where you're watching us from. Let's know your school. Please introduce yourself. Y equals to 4, not y equals to 2, not 4. 2, not 4. Okay, 2, not 4. 2, not 4. Let me check. Y equals to 2. Very true. We wrote a 2 here. Actually, I was using the wrong value. Sorry for that. And thank you for the good concern. The first value equals to 2. So we will say, after introducing the 3 power 2 is the same as k. 3 power 2 is the same as k. Thank you so much for that good correction, for that genuine concern. So we talk about 9. 3 power 2 is 9. So thank you for that. The first value was 2 and not 4. Yeah, thank you. 2 and not 4. Thank you, thank you, thank you. Now, to apply this, we need to take, we have a third. So we take the square root of a third. Then now we cube. get k. The square root of a third. The square root of a third. Then we raise it to power 3. This is k equal to 0.1925 to 4 significant figures. Please use your calculator to confirm the same value. Confirm the same value with me. Thank you. Thank you for following up. Thank you. Thank you, guys, for checking our work. Now I'm supposed to mention a few things here. For the guys who are following us and those who are subscribing, I can see subscribers are increasing, meaning that the guys who are live with us today are doing a great job of subscribing to this platform. Remember to share with friends apart from just subscribing. Invite your friends to our best online school. So to check a few guys, I have just seen a great friend of mine, and that is from the comments. Did you disappear? On behalf of Ascending Grades following, that is Johnston Mbula. Thank you so much for being around, Malimu. That is a physics chemist teacher, a very wonderful teacher with a program on YouTube. Kindly ensure to follow up with his work, Ascending Grades on YouTube. Please check on him. A good prediction, all right? Elias from Kiambu, Kikuyu, math teacher, Madam Kinywa, Mohu Secondary. Wow. Thank you, Clement, from Bomet County, watching live. Thank you so much. That is from Tebeswet High School. Kisumu boys in the house. Thank you. Mr. Mbola is the math teacher to that gentleman. Bishop what? Hey. Somebody is advising you guys to subscribe. We are already 43 actually. 43 following live. So that is so great. Remember our consultation line. Is 07. Let me put it somewhere clear. 0704 153366. This is our consultation line, which also happens to be our M-Pesa line. So you can use it accordingly. And thank you. Bless you from Kirigara Girls. No problem. You can see she's late. Let's remember this. We are having some serious platform here. This one is a mentorship program. I mentioned it when we were starting, but because some people had not joined us, I'm going to do a repetition. Term 3 2025, every weekend, we shall be having a mentorship program on mathematics for all the candidates. Those who are waiting for the grade 9 examination, every Saturday from 7:30 p.m. to 9 p.m. Then for the Form 4 students waiting for the KCSE, every Sunday from 7:30 to 9. Please register for this platform. It shall be happening on Google Meet, whereby it is one-on-one. In that platform, you can unmute to question, you can unmute to respond, you follow up one-on-one. It's just as interactive as an ordinary class. Those who are in the lower forms, be reminded of our August program. Not August, sorry, but December, November program. What are we calling it? One term ahead program. In this one, we're going to ensure that you guys cover the work for January 2026, so that when you'll be reporting back to school in January 2026, you shall be one term ahead of the other friends. So please enroll to our programs, even those with those in junior school, grade 7, 8, and 9 of next year. Please enroll. Please enroll. It is going to be 5 weeks of a very great interaction. Subjects are going to be communicated, but be ready for the compulsory subjects only. We're going to get the best teachers for you from the country. So thank you so much for following up. Let's now get back to the paper. What are we told in number 5? We are told this. The figure below is a rectangle, ABCD. The figure below is a rectangle ABC. We can see the rectangle, right? We can see the rectangle. Those in boarding schools, thank you for the good concern anyway. Those in boarding schools, kindly, through your teacher, because in term 3, we are going to be releasing very powerful presentations, and the final touches in our predictions. Those in boarding schools, through your teachers, kindly, make sure you can find time. You can also inform your teachers about shifting grades online school. After informing them, they'll be finding time to get papers through us. Advise them to get our number from the platform. We are going to share the papers for free. Our prediction papers will be coming for free, and I hope you guys shall benefit from the same. So your teacher will be getting papers for us. Those with screens, remember nowadays we are integrating learning with ICT. There are people with smart TVs whereby they just open their YouTube from class on the screen and they follow up with shifting grades plus other platforms. So through the guidance of your teacher, you can also be following up with our platform even when schools have been opened. So you are not limited, kindly. You are limited not. Look at the rectangle now. It is here. This is a question on LOCI. Now, in part A, we are told, using a ruler and a pair of compasses only, construct a locus T that is equidistant from AB and BC. T intersects CD at H. Now, let's check that. For us to ensure that we have a locus, seriously now, some people think that locus is difficult, yet it is the simplest topic. To ensure that you draw the locus of points which are equidistant from two given lines. What you are given here are lines. Line A, B, and C. So equidistant points from two given lines is the bisection of the line, or the bisection of the angle where the two lines meet. So where AB and BC meet, we bisect the angle there. AB and BC, we bisect the angle. So the angle at B should be bisected. You stand at B, you make an arc, you make an arc. Then standing on those arcs, you make other arcs like that. Then now you produce that bisector. You will have bisected the angle. You will have bisected. That is now what we are calling. That is what we are calling a T, the locus T. Sometimes you'll be told to plot the locus of points that are equidistant from A and B. That means equidistant from two fixed points. For points to be equidistant from two fixed points, you are supposed to bisect the line joining A and B. But have we been told that? Not really. We've not been told to do that. Look at part B now. Shed region R inside the rectangle such that part 1, we have three conditions here. Part 1, in part 1, the angle ABR, that means AB is at the center, and also CBR, the angle ABR is less than CBR. First, I want you to take this one serious. For you to deal with inequalities, first come up with the equations which are going to be plotted to represent the inequalities. Then from there now, you will use the inequality to know which side to be shaded. So when we talk about angle ABR being equal to CBR, you see B is a common point. So the angle at B should be bisected. The angle at B should be bisected. Now, when the angle at B has been bisected, something which has already been done, now we're going to ensure that we shed such that the angle ABR is the one which is less. So for the angle to be less, then it means we are supposed to be within the region AB. We're supposed to be within on the lower side. So the upper side is unrequired for this line. We have noted that the upper side is unrequired. The upper side is required. The upper side is required that way. No, the lower side of this line is the one that is required. Okay, check Roman 2. AR to be equal to BR. So for us to come up now with this, we need to identify where R is, such that when you are at R, you are at an equal distance to when you are at B. And that means we bisect now A and B perpendicularly. So bisecting A and B perpendicularly will give us a very straight line. That way. Then we are supposed to ensure that from A to R is greater than from B to R. If from A to R is greater, then we means at R should be beyond the line. For AR to be greater, it should be beyond the line. For AR to be greater, it should be beyond the line with reference to A. If it was BR to be greater, it could have been, the required side could have been on the side of A. But now that we want A to R to be greater, then R should be either at the line or beyond the line. Good work. Look at part 3 now. BR to be equal to 3. So we want to draw a locus such that while standing at B, we have to be 3 centimeters away. The locus of points which are from a fixed distance at a given distance. In such a case, we are supposed to draw a circle which is 3 centimeters standing at B. So we are going to use B as the center and the 3 as the radius to draw a circle. One thing that you're supposed to know again is that the inequality is strictly greater than. So it is a dotted arc. The arc is supposed to be dotted. This one is supposed to be dotted. So from B, we use 3 centimeters to draw an arc. To draw an arc. So I've drawn an arc which is dotted using 3 centimeters, and it is supposed to be within the rectangle. Therefore, for BR to be greater than 3, it should be beyond the arc. Therefore, R now is going to be at this point. Anywhere here shall be point R. Beyond the arc, and for the perpendicular line on line AB should be to the right, and for the line that we drew from B, the bisector of B, it should be on the lower side. So the region has met all the requirements. It has met all the requirements. So thank you so much. Thank you so much for that. Thank you for understanding that part. We check number 6 now. We check number 6. Very serious question here. We check number 6. We are told something here, very serious, to expand 1 over x plus 2 to the power of 6 up to the 4th term. Very serious instruction, which is supposed to be followed up to the 4th term. Hence, we use the expansion to estimate 2.1 power 6. So we're going to first expand. How shall we expand? By first of all, listing the binomial coefficients when the power is 6. So what are the binomial coefficients of power 6? We start with 1, the first term, 6 as the second, 15 as the third coefficient, then 20 as the fourth. And remember, we've just been told to expand up to the 4th term. So with such instructions now, we just list up to the 4th. James Muasia, thank you so much for following together with everybody else. Thank you, Kiprotich. I can notice your presence. Moani Boys High School, thank you so much. Okay. Check this now. Check this. We start with the first term, 1 over x. This one, as we start, is supposed to take power 6. And the second term, which is 2, is supposed to take power 0. 1 over x power 6 and 2 power 0. There are 2 terms. That's why we call it binomial expansion. But as we proceed now, in the second term, 1 over x starts taking power 5 as 2 takes power 1. So the powers of 1 over x increasing as the powers of 2 power 4, so that the powers of 2 now become 2. So the powers of 2 are increasing. Here, 1 over x decreases to 3 and increases to 3. Like that, a seesaw game. So from this point now, we can see this is 1 over x power 6. Then we multiply by anything power 0 is 1. So 2 power 0 is just 1. Then we go to the next term. The next term shall be 6 multiplied by 1 out of x power 5. So that's 1 over x power 5. Then we are also having 2 power 1. Anything power 1 remains the way it is. If anything power 1, Utawala, I see you, Utawala High School, thank you so much. If you are day scholars, please remember our program. For day scholars, let's remember that we'll be having mentorship programs on every weekend. And this is on Sundays for the Form Force, strictly for candidates. Strictly for candidates, unless we are very serious students in Form 3 who would like to join us. But this is preserved for the candidates. Remember to enroll by reaching out through our number, which is already on the screen, 0704 15 3366. You reach out, the number is already here, so that you may get more details about the same. But the platform shall be Google Meet, which is very interactive. So let me have all the scholars coming on board, please. Day scholars, please come on board. Mandera, thank you. Yeah. Okay, check here. Anything power 1 remains the way it is. So we'll be having 6 times 1 times 2. That is just 12. But now x is at the denominator and it becomes power 5 that way. Plus, at the third term, 5 times 1 power 4 is just 1. 2 power 2 becomes 4. So 15 power 4, 15 times 4, sorry, which is 60, out of x power 4. Then plus 20 multiplied by 1 power 3, which is just 1, and 2 power 3 is 8. So 20 by 8, giving us 160. Then x is now power 3. That way, we have the expansion already. We are having the expansion. Now with the expansion up to the fourth term, and remember, the first term can still be written as, 6. Yeah, that is 6. Because 1 power 6 shall just remain the same. Yeah, 1 power 6 is just the same. 1 power 6 is just the same. Okay, check here. After expanding that way, we now relate the expansion, not the expansion, we relate, this term with whatever we've been told to estimate. So 1 out of x plus 2 equals to 2.1. So with this now we can say 1 over x equals to 2.1 minus 2. That gives us 0.1. I hope you are following keenly. So we can remain with 1 and multiply by x both sides. We remain with 1 and multiply by x both sides to have 0.1x. So with this, we can now say x equals to, we take 1 and we divide it by 0.1 to give us 10. So the value of x is 10. The value of x is 10. Now we use this to estimate by doing this. We go back to our expansion and write 1 out of 10 power 6 plus 12 out of 10 power 5 plus 60 out of 10 power 4 plus 160 out of 10 power 3. Yeah, out of 10 power 3. That is it. Wow, thank you, Nyakach girls. Thank you so much. Please bring on board your friends from your schools. You know, some people are coming from very serious schools. Ruaraka High School, thank you. Nairobi. Moffat from Ituru Boys, thank you so much. Mandera School, thank you so much. Utawala, thank you. Thank you, Garissa High. Thank you all for attending. Greetings, sir. I receive your greetings. Thank you. Amos Karema, Kilifi County, thank you. Thank you. We have Ruaraka High, thank you. Kipkeino, thank you so much. Bookshine Secondary School, thank you so much. Vitengeni High School, that is in Kilifi, thank you. Eldoret, thank you. Thank you, ladies and gentlemen. Thank you, ladies and gentlemen. Thank you for finding time to just follow up with our program. Just thank you so much. Ugenya, if you think I'm not mentioning your school, you can kindly repost. I'm not planning to ignore anyone. Madam, by any chance, Madam Boya is your principal? Okay, thank you. Those are interacting there. Kitui School, wow, thank you, Kitui School. Thank you. And make sure, as you exit Form 4, if you're in Form 4, following from home, thank you. As you exit Form 4, kindly. As you exit Form 4, please leave some people that you are mentoring having enrolled in shifting grades. Make sure you make some people enroll to our program. Now we can check this for the scholars. I mentioned that I'm repeating. We can now get back to the question and use our calculator so well. We use our calculator so well. Let me check whether this will give us the right value. So I'm just using my calculator, and listen to me, the things I'm talking about. I'm going to take my calculator and I write 1. 1 should be divided by 1 should be divided by, I open brackets, 1, I'm starting with opening of brackets, divide by 10 power 6. Then I add, I open brackets again for 12 divided by 10 power 5. I add and open brackets for 60 divided by 10 power 4. I close, I add and open brackets again for 160 divided by 10 power 3. Then I close brackets for that. The answer that I'm getting, ladies and gentlemen, I'm going to write it here. The answer that I'm getting is 0. I'm getting a 0.16612. Okay. According to how the value is, this is something that I'm supposed to suspect that it is wrong. Yeah, I already suspect this kind of an answer. I don't know where we're making the mistake. Maybe in the computation, or we can do this. Actually, let me check the approach. Because in case we take 2.1 and I raise it to power 6, I will not get 0 point. So maybe I'm typing something wrongly in my calculator. So I'm having 1 into x power negative 6. I'm just making it the numerator. Yeah, I'm making it the numerator like that. Then plus 12 into x becomes power 5, but now negative. Then plus, I'm just on this expansion, trying to modify it to see whether it can become simpler. 60 x power negative 4. Then plus 160 into x power negative 3. We make them numerators and we change the sign according to the laws of indices. So 1 into 10 power negative 6 plus 12 into 10 power negative 5 plus 60 into 10 power negative 4 plus 160 into 10 power negative 3. Remember, this one we shall attempt until we get it right. Waithaga boys. Oh, thank you. Daraja Academy, thank you. Daniel from Sawagongo National School. Wow, thank you. Mariakani Secondary, thank you. Aldina Visram Mombasa, thank you. Okay, now check this. 10 to the power of negative 6. Then I add 12 into 10 to the power of negative 5. Then I add 60 into the 10 to the power of negative 4. Then I add 160 into 10 to the power of negative 3. Aha, I'm getting again 0 point. I'm getting again 0.166. That means there is a mistake happening somewhere, and I'm going to vet that mistake. Let me ship out the mistake very quickly. We get back to our question. This was very well executed. The next part should be 12 over x power 5, well executed. This one is a 4 by 15, 60, x power 4, well executed. Then here we have 8 times 20, 160 over x power 3, well executed at that point. So now we have to check. We have to check now the next. We have to check the next. 2.1. X over that equals to 2.1. So with 2.1, we can remain with 1 over x. So that 2 is subtracted on the other side to give us 0.1. Then by x and by x. So we'll be having 0.1x equals to 1. So that the value of x is 10. The value of x is 10. Then now 10 should be replaced. 10 should be replaced in the equation like that. All right. So I think according to the first 4 terms, we get a value which is not very close to the answer. Yeah. Which is not very close to the answer. And this is a 0 point. People can also attempt 1661 according to the first 4 terms. Maybe the accuracy is approached as we use all the terms. So please try that one in your own time and check whether you can obtain a different value. Meanwhile, we can now proceed to number 7. The roots of our quadratic equation are negative 2 over 7 and a third. Form the quadratic equation in the form ax squared plus bx plus c then equals to 0, where a, b, and c are integers. Check these. X equals to negative 2 over 7, meaning that x plus 2 over 7 equals to 0. I've just taken it to the left-hand side. Then we are told that x is also a third. Now, if x is a third, this will imply that x minus a third is equal to 0. If this is so, then we can also talk about x plus 2 out of 7. This one multiplied by x minus a third would give us 0 that way. So at this point now, we can talk about it still gives the same answer. Okay, thank you so much for following up. Thank you for confirming that. We now proceed. Let's now expand this. To expand this, we start with the first term, which is x, and we multiply with everything in the second bracket. Then plus 2/7. This one also multiplies everything in the second bracket, equals to 0. At this point, we can say x squared after opening brackets minus a third x plus 2/7x minus 2/21. Yeah, negative 2/21 equals to 0. This is equal to 0. So we can group some terms. X squared is already alone. We don't have any other term which is equal to that or the same as that. Negative a third, we add 2/7. This is giving me negative 1/21x. Then minus 2/21 equals to 0. I hope we are together there. Thank you guys. You are turning up in very good numbers. Remember to subscribe. Remember to comment. Please let us know where you guys are watching us from. Please let us know where you're watching us from. Let us know who you are. Let us know your good secondary school. Please recognize your good secondary school tonight in this presentation. Okay, today. I know we are doing it during the day. And some people will also be watching at night. So when I say tonight, this morning, this afternoon, I'm saying that because I'm sure that people will be watching these videos at different times of the day. So thank you for watching us. Please remember to subscribe. Thank you so much. Yeah, your subscription is the greatest reward to this particular platform. Ushirika Sek in Nairobi. Thank you so much. Thank you so much. And I'm still commenting all the scholars to our program during term 3. During term 3, the scholars will be fully occupied through Google Meet. Very interactive, where they can ask questions, whereby we'll be giving our final predictions as we approach the national exams. So please remember to inquire about the same. Our number is attached, 0704153366. That's my number. Please reach out for the program. At this point, we are through with the equation, but the examiner now wants integers, not just constants, but integers. So to ensure that they are integers, we can multiply by which LCM? Okay, which factor? What about vectors? We're going to see some vectors here, and also the vectors in section 2. We can multiply through by 21. When we multiply through by 21, we get 21x squared. But now 21 simplifies at this point to just have it as x, and here to just have this one as 2 equals to 0. So according to the instructions, we have now arranged the equation, ensuring that the constants are integers. That way, the constants are integers. We have multiplied through by 21. Thank you so much, Ken, from Kenneth from Gitundu. Kenneth Gitundu from Giakancha School. Thank you. We notice you as one of our good fans. Was in Gishu High in Eldoret, from Mangu High. Wow, thank you. Thank you guys from Mangu and any other school. Make sure that you leave people in your school knowing about the platform that has helped you to pass in mathematics. A very good question, number 8. There is SURDS. We did SURDS already in this paper, and we have done SURDS in most of our papers. Remember, we have more than 2,000 videos which have already been presented. So even if we are not live, I recognize Sironga Gauss. Thank you, Sironga, for being around. And remember that we have more than 2,000 presented videos. So even if we are not live, you can still keep yourself busy with very good papers which have already been uploaded. Thank you. The figure. And remember, in our programs, if you are the scholars now, in our programs, which I was talking about, this is where This is where we will be discussing those individual questions now. The topic that you feel we should discuss, we'll be bringing it on board during such sessions. For the Form 2s and Form 3s, and the grade 9, grade 8, and 7 students of next year, we're going to have the one-term ahead program, whereby we shall cover term 1 2026 work. In this one, you are going to get the best. We're going to clear all the work, and you shall report when you are ahead of the other students. So please enroll to our good programs and get the best. The figure below shows a circle inscribed in a triangle XYZ. XP 3 centimeters, as you can see. Then PY 2 centimeters, you can see on the diagram. Then X all the way to Z is 7. XZ 7 indicated very well. Calculate the distance YZ. The base, calculate the base. If this is a circle and it is touching the sides, then it means we have some conclusions that we can make. And one is that this part and this one are supposed to be both 3. If that is so, let's get to the whole distance XZ, which is 7, meaning that this alone is just 4. This is 4 centimeters that way. If that is 4 centimeters, let's also know that with 2 here, we will have another 2 at that point. Then again, with 4 as RZ, then QZ shall also be 4. QZ shall also be 4. Because they are both tangents of circles. They are tangents to this circle. I want to talk about now that property. One day you'll be taught to construct. In paper 2, section 1, you'll be taught to construct a tangent to the circle, or 2 from a circle, such that from one common point, we have 2 tangents to the circle. So those tangents are always equal. So if we talk about tangent X, equal because they are from the same point to the same circle. They are both, and if we are having another tangent from Z, ZR and ZQ, because they are both from a common point and to the same circle, tangents are also equal. So that's why we have 4, 4. Then now another tangent or another pair of common tangents, we have YP and YQ, 2 centimeters each. So now for us to get the length Y to Z, 2 and 4, this is going to be 6 centimeters. 6 centimeters. Thank you for following that part. And I hope you have gotten it so clearly. I hope you've gotten it so clearly. So thank you for finding time to follow. Thank you for finding time to follow up with it. Okay. That was number 8. We check number 9 now together. Number 9 together. Let's check this one. The volume V of a cylinder varies jointly with its height and the square of its radius. Okay. Determine the percentage increase in the volume of the cylinder increases in the ratio 3:2, and its height decreases by 30%. Okay, let's write first of all the statement here. I'm going to use the space up there. V directly proportional to height and square of radius. Square of radius that way. If we have this, we can introduce a constant like that, equal sign and a constant, then H R power 2 that way. So this is the original expression for volume. If that is the original expression for volume, we can do some interpretation now of the more information. Percentage increase in volume of the radius of the cylinder if its radius increases in the ratio. So the new radius, we will have a new radius whereby increasing in the ratio 3:2 means 3 out of 2 of the original one, which is 1 0.5 R. So the new R is equal to 1.5, the original R. What about, that was for radius. What about the height? The height decreased by 30%. The new height will be, because it has decreased, shall be 70% of the original height. So 0.7 of original height. The new height becomes 0.7 or 70% of original, just by the fact that it decreased by 30%. So it became 70% of original. 70% of original. 70% of original that way. With that statement now, we can now say that if we have the new R and we are also having the new H, we can express the new volume. The new volume shall be, and be careful in this as you watch what I'm saying, a constant multiplied by the new H now. New H is 0.7 of original H, then multiplied by the new R squared. New R is 1.5 R, we square. New R squared. It's being squared. This is 1.575 times a constant times H times R squared. So this is the new volume now. A new expression for the volume. How do we get percentage change? Percentage change in V will be given by the new V minus the original V out of the original V. Then we multiply by 100%. So this shall be the new V, which is 1.575 KH R squared minus the original KH R squared out of original KH R squared, that way. Then we are supposed now to multiply all this by 100%. So with this now, we shall be factoring out KH R squared into 1.575 minus 1, the one that remains, out of KH R squared. So this can now cancel that way. Remember, we are supposed to multiply by 100%. So this shall be, when we subtract 1 from this, we get 0.575 times 100. When we multiply this by 100, guys, we shall have 57.5% increase. 57.5% increase. 0.5% increase. Yeah. 0.5% increase. 0.5% increase. Percentage change in quantities. Percentage change in quantities. And wait, are you guys subscribing? Are you sharing with friends? Okay. Are you commenting? Let me check your comments. I'm back to the paper. I'm back to the, back to the studio as we check number 10. Be reminded of our consultation line, which is 0704 15 3366. And I said this is also our M-Pesa line. Yeah, those who feel that they can support our program, you are very free to use that number. You are very free to use that particular number. When I look at this, I can see guys from LOCI Mixed School. Thank you so much. And as we continue covering, let the scholars be reminded of our serious programs here during term 3. During term 3, we shall be having our programs there. So please make sure. Alliance High, thank you so much. Moani School, thank you. Kirenga Boys, thank you. Sironga Girls, thank you. I can see people from all over Kenya, from Mango School, thank you. So thank you so much for following. Now we check number. Together we check number. The next question, which is number 10. So let's get to number 10 now together. The position vectors of P and Q are given as P, 4i, 3j plus k, and also Q equals to 7i minus 3j plus 4k, respectively. Another point R is along the line PQ, such that PQ to PR equals to 3:4. That's a serious ratio. You're supposed to be very serious when interpreting that. Find the position of R. Find the position of R. So R is somewhere along. R is somewhere along P, Q. P, Q. Position we can write them now as 4, 3, and 1 from these. From the unit vectors now. 4, 3, and 1. Then 7, -3, -3, and 4. 7, -3, and 4. 7, -3, and 4. 7, -3, and 4. That way. So now let's interpret the ratio so that we may fix R. R is somewhere such that from P to Q, look at this. From P to Q, those are 3 proportions. And again, from P to R, we have 4 divisions. 4 divisions. So it is along this line. And that is to mean that now it is an external divider now. So R is going to be at this point. It is dividing it externally. X, Y, Z, unknown. I don't know whether we are together in that interpretation of the ratio. When we are talking about PQ, 3 proportions. It means we have 3 here. Then we are also talking about, again, PR. That means from P to where R is, we are having 4 proportions. So if there are 4 proportions, it means now we have an additional 1 proportion there. Wow, a very interesting question in ratios. Proportional division of a line. This is among the questions that you should take with a lot of seriousness, because now the ratio is stated in a positive way such that you cannot understand that point R is an external divider, external division of a line. So this is now external division of lines. External division of lines. Yeah, external division of lines. External division of lines. So look at this now. With that external division of lines, we can now find the position of R, whereby we will say, according to the ratio theorem, let's assume that this is a ratio of M, and here we have a ratio of N. We usually say this in proportions and the ratio theorem. When we take M and we divide by total proportions, M plus N, then we multiply by, if we have picked M, we take the opposite ratio, which is R, the opposite vector, which is R. Then we add, we pick N out of total. Then now, because we have picked N, the opposite vector P, this is the ratio theorem, we are supposed to get position of Q, which is the middle, the middle vector that way. We get the middle vector that way. So with that, now we'll talk about 3 out of total 4 proportions. We multiply by unknown x, y, z. Then we add n, which is just 1, out of total 4. We multiply this by 4, 3, 1. We are supposed to get the middle vector, which is 7, -3, and 4. 7, -3, 4. So now we can work out the x component. 3/4 of x plus 1/4 by 4 is 1 equals to 7. 1/4 by 4 is 1 equals to 7. Then now we can remain with 3/4 x equals to 6. How do we get x then? To get x, we have to multiply by 4/3, both sides. 6 times 4/3. I'm getting 8. X is 8 that way. After that, we can proceed to find some other coordinates there. We can go to that was x. We go to y and say, again for y, 3/4 of y plus 3/4, because of 1/4 times 3. 1/4 times 3, we get 3/4. Then this is equal to -3. Yeah. With that, we can talk about 3/4y equals to -3 minus 3/4. -3 and 3/4. So how do we remain with y? We multiply by 4/3 both sides. By 4/3 on both sides. That gives us -5 after multiplying by 4/3 on both sides. At this point, at this, can you repeat, sir? Okay. Check here. We are at z now, whereby we have 3/4 of z plus 1/4, because 1/4 is now being multiplied by 1. This is equal to 4. So 3/4 of z equals to, when we take 4 and we subtract 1/4, what do we get? 4 minus 1/4 equals to 3 3/4. 3 3/4. 3 3/4. 3 3/4. Whereby now, to remain with the z itself, to remain with z, we are supposed to multiply by 4/3. 4/3. That way, this becomes 5 positive. With that now, we can describe the position vector of R. Position vector of R, which can be given by letter R now, is going to be equal to 8I minus 5J plus 5K. Because as a column vector, we are having 8, -5, 5. Yeah, 8, -5, 5. 8, -5, 5. That way. So now the position vector will be given that way, just as the other position vectors were stated that way. So please follow up with our program so that you may know how to express ratio theorem well. But just to repeat something on the ratio, we were told this, that R is along PQ, and PQ has been drawn such that PQ to PR equals to 3:4. To interpret these ratios, this is what you're supposed to know. What you're supposed to know is that if we are told PQ corresponds with the first proportions there, which are 3, then we say from P to Q, we are having 3 proportions. Then again, from P to where R is, we are having 4 proportions. So from P to where point R is, proportions are now 4. That means you will go beyond Q. So R becomes an external divider of PQ. Because from P to R, we are having 4 proportions. If the proportions are 4, then now from Q to R, we shall have 1. That's why we have 1 there. We shall have 1 at that point. I hope it is well repeated, and I hope you've understood, you guys. This is form, okay, form 3, vector 2, proportional division of a line. Thank you, Kisii School. Nyakach girls, thank you so much. Thank you, Kitui School, not Kisii, sorry. Thank you. We have Engineer Sigei from Legacy Engineering Limited. I am always available here. Thank you so much, Engineer. Now we can proceed to number 11. A very good questions from matrices and transformations. Okay. A transformation T, 1, 0, K1, maps point P to P prime. That is 2, 3 to 2, 10. Determine the value of K, hence describe the transformation. So we're going to say that matrix times object gives us image. If we know this, then we will say the unknown matrix that way multiplies P to give us P prime, which is P prime, which is 2, 1, no, 2, 10, that way, to give us 2, 10, yeah, that way. So we will say that for us to get the coordinate here, which is 10, we know the multiplication of matrices, right? So when we take this second row times this column, we are supposed to get the value here at 10. So 2 times K and 3 times 1 is supposed to give us 10. You saw that? 2 times K, 3 times 1 should give us 10. If that should give us 10, then we can talk about 2K being equal to 7 after taking 3 to the right. So the value of K shall be 3.5. Now the matrix is 1, 0, 3.5, 1. This is the matrix now, but the main thing was determining the value of K. Then now we are supposed to state or to describe the transformation. When a transformation is of this nature, you're supposed to know that this is a shear y-axis invariant. This is a shear y-axis invariant. A shear y-axis invariant. There is something you're supposed to know. That is a general. This is a specific one. General 0, K1. This one is for shear when the y-axis invariant. Then we can also have a 1, a constant here, then 0 and 1. This is going to be a shear x-axis invariant. X-axis invariant. We can have a matrix of transformation, which is a constant 0, 0, and 1. This one now, this is for a stretch y-axis invariant. A stretch y-axis invariant. When it is in this format, this is a stretch y-axis invariant. I'm transferring the term there to avoid a lot of writing. Then when we have a 1, 0, 0, K. This is going to be a stretch x-axis invariant. X-axis invariant. X-axis invariant. So that is it. X-axis invariant. So in case you're taught to describe, just master those general matrices. Number 12. Let's look at number 12. The diagram below represents a right pyramid standing on a rectangular base. A right pyramid on a rectangular base, ABCD. V is the vertex. V is the vertex of the pyramid. V is the vertex of the pyramid. And VA is the same as VB, VC, VD, 26 centimeters. Those are the slanting heights. Those are the slanting heights. I'll be checking your comments. Just continue commenting. Kaimosi, I notice you. We'll be looking at that later. Okay, we are also having AB as 24 and BC as 18, as you can see, even according to the diagram. Now, what are we being taught to calculate? Calculate the angle between the planes VAB, we can see it. Then also another plane is BCD. So we can see BCD. These are two planes which are meeting at the vertex. Two planes meeting at the vertex. So to work out the angle between them, we are supposed to know that we need to draw from the first plane through its center. That way, we've drawn a line through the first plane. Then we also draw a line through the other plane until where they are meeting. From the other plane also, until where the two planes meet. You see that? Until where the two planes meet. Then if we let this one to be X and the other point here to be Y, we can get the angle at V. That is the angle between the two planes. The two planes are meeting up there. So we get the angle now between at the center, that point now. We have to calculate that angle. How do we calculate this angle, ladies and gentlemen? Let me extract first the triangle in a better way now. Now that we have identified it, I've picked from V. Through the center, I have X and Y. Now, from X to Y, let me even indicate it on the diagram. From X to Y, that is a distance equal to 18 centimeters. That distance is equal to 18 centimeters here. 18 centimeters, just like BC. Just like BC, it is 18 centimeters that way. So which other values do we know? Which other values do we know? We can get the slanting height from B to X. We can find the slanting height from B to X, which is also the same as the slanting height from B to Y. So from B to X, how can we find B to X? This is right angled. So we can use 26 and half of 24, which is 12. Half of 24, which is 12. So we say for us to get Vx, we need 26 squared plus 12 squared. Then we take the square root. And then we take the square root. 26 squared plus 12 squared. Then the square root. We get 28. Not really. No, not really. 26 is a hypotenuse. Not really. We are supposed to subtract. Not really, not really, not really. This one we subtract. Sorry for that. 12 squared. Yeah. So 26 squared minus 12 squared, we take the square root. This is going to be 23.07. 23.07 that way. 23.07. So now, if this is 23.07 now, we'll be having 23.07 0.07 also on the other side. With that information, we'll be able to know that now angle at V. For us to find the angle at V, we can bisect like that, so that we have 9 and 9 here. Then we deal with one acute angle and we multiply it by 2. One acute angle, then we multiply it by 2. How do we get the angle theta at this point? With the angle theta at that point, what we have is the opposite length and the hypotenuse. So we're going to use now sine. The sine of that angle, sine theta, equals to opposite 9 out of hypotenuse, which is 23.07. When I divide that, I'm getting 0.390199. Okay, such a thing. So that theta becomes now sine inverse of 0.390199. So you go to your calculator, shift sign of this value. I'm getting 22.97 degrees. So that the angle now that we wanted becomes 22.97 times 2. When I multiply this by 2, ladies and gentlemen, I'm getting 45.93 degrees. Yeah, 45.93 degrees. For those who are joining us late, if you are a day scholar and you are in Form 4 or Grade 9, please follow up with our Term 3 programs. Very serious mentorship programs for the candidates of 2025, whereby we shall be discussing mathematics. For Grade 9s, Saturdays on 7:30 at 7:30 to 9. On Sundays, we'll be having the Form 4s from 7:30 to 9 p.m. So please follow up with our programs. Follow up with our programs like that. Okay. Number 13. We are almost winding up with section 1. Ladies and gentlemen, section 2 will be discussed later. But for now, we finish up with the section 1. Remember to subscribe. Yeah, remember to subscribe. Just remember to subscribe to our platform. A trader did what? Mixed rice grade A costing 150 per kg with rice grade B costing 120 in the ratio of 5:1. So in every 5 kilograms of A, there were 1 kilogram of B in order to make X. In what ratio should grade B be mixed with the blend X to make Y costing 135 per kilogram? So let's know, because we know what B costs, let's know what the blend X is going to be costing. So brand A costing 150, we have 5 kilograms of that, plus 120 for B. We mix only 1 kilogram there. That is the cost of the kilograms mixed, which are 6. So we are supposed to divide this by 5 kilograms and 1 kilogram. So that we know the kilogram of X, what is it costing? 150 by 5 plus 120. This is 870 over 60. Over 6 kgs, that is. So the cost of X, blend X, will be 145 Kenya shillings. So we are coming up with blend X costing 145 per kilogram. 145 per kilogram. Then at that point, we shall also say this. At the same point, we'll be saying this. At the same point, we shall say this, that we mix now 145, that is X. We mix X kilograms with we are mixing a B with X. B with X, okay? B with X. Let me begin with B with X. This is for X. This one is for X. This is for X. So we start B, which costs 120, plus X costing 145. So that we may get Y. That costs 135. So here we have mixed B and X kilograms. So that when we divide by the total kilograms, we get 135. Did you see that? We get 135 that way. I know there are some faster methods of doing this, but have 120B and 145X to be equal to 135 by B, 135 by X. We group terms. For B, we have them to the right. 135 minus 120, we get 15. 10B. For X, 145 and 135 we subtract, we get 10X. So how shall we remain with B? We remain with B by dividing by 16, by 15. Then how do we do away with X? To do away with X, we have to divide it through by X that way. So at this point now, we shall be having B is to X, 10 is to 15, but our ratio is supposed to be in the simplest form, by 5, 2, by 5, 3. That way. So the ratio is 2/3. Remember, we can still take B costing 120 and X costing 145. We want to mix them until we get 135 as Y. So we can do this simple method, which is approved anyway. 120 minus 135, the absolute difference is 15. 145 and 135, 10. So the ratio of B is to X should be 10 is to 15, which is supposed to simplify to 2 is to 3. So the same method of ratios can be done using this approach. It can also be done using that particular approach. So thank you for that. Thank you for that. Yeah, thank you for that. Thank you for that. I know some people will be surprised. They have never seen us live streaming during the day. Kisii School, thank you. Moi High School, thank you. Kaimosi, thank you. What about Form 2? We have a lot of content for Form 2. Every paper 1 contains Form 2 work. A lot of Form 2 work. So we are doing a lot of Form 2 work. Just relax. There is a lot of Form 2 works. A lot of Form 2 work. We continue checking. Number 15 now. A circle center D, which is 2, -1, passes through points P, -6, 5. Find the equation of the circle in the form, okay? We can't find the equation of a circle unless we have both the center and the radius. So from the center to a point where the line passes, that will give us the radius. So the radius should be the magnitude of vector dp. The magnitude of vector dp will give us radius. So let's get radius first. Vector dp requires a p minus d. This is -8 and this is a 6. I hope we are together in that. -6 minus 2, we get -8. But 5 minus -1 becomes 6. So now to get the r, we're supposed to take -8 squared plus 6 also squared. R is going to be 64 plus 36, 100. The square root 10. 10 units. Yeah, this is 10 units that way. 10 units. With radius now, we can express our equation of a circle. Generally, the equation of a circle is given by x minus a plus y minus, squared, sorry. Y minus b squared, radius squared. That is the general equation of a circle. A and b are the coordinates of the center. So we talk about x minus 2 because the center is here. We square plus y minus b. Remember, it's a 1. It's a negative 1. So minus negative 1 squared equals to radius squared. So this is going to be x squared minus 2 times x times negative 2 becomes a 4x plus 2 squared, which is 4, plus y squared plus 2y plus 1 equals to 100. Then according to the format that we've been advised, we start with x squared, then the term with y squared, then we go back to x, then y, then now we are having 4 plus 1, and we subtract 100. We get negative 95 equals to 0. So now this is the equation in the format which has been dictated by the examiner. Equation in the format dictated by the examiner. Remember to subscribe, guys. Remember to share with friends. Just remember to invite some people. Just remember to invite some people to this particular broadcast. At number 16 now. The graph below is a displacement time graph for a kite launched upwards from a height 20 centimeters high. So from 20 centimeters high, we throw it upwards. This is how it behaves. Just as you can see the curve. It's a vertical projection. Determine the rate of change of displacement at t equals to 5. At t equals to 5, which is this point, at t equals to 5, which is this point, we're just supposed to draw a tangent to the curve at that particular point. A tangent to the curve at that particular point. Remember what a tangent is? A line which is just touching the curve without passing through it. That way. That way. So after drawing the curve, now we're supposed to pick 2 points lying on the tangent so that we may calculate the gradient. 1 point is 525. Then we just pick another 1 more point. So another 1 more point on this tangent. 1 more point on this tangent shall be, you can use this. I'm having 1.530. 1.530. 30 minus 25. Out of 1.5 minus 5. This is going to be 5 out of 1.5 minus 5, negative 3.5. So 5 divided by this, I'm getting negative 1 and 3/7. Yeah, this is a meters per second. Meters per second. The height is in meters seconds. So remember now, this rate can be given as 1 and 3/7 meters. Yeah, because rate of doing work is supposed to be positive anyway. Yeah, the rate of doing work. That is just, the negative is just to show direction. This is Shifting Grades Online School. Shifting Grades Online School. So thank you so much for following up. Jora Secondary School, very serious schools here. PC School, I notice you. Thank you so much for being around. I want to wish you all the best as you continue revising for the national exams. See you another time. See you another time. See you another time. For the day scholars, welcome to our platform. We are going to be here. We are going to be here for long. All the best. Kisumu boys, thank you.